Hello everyone and welcome back. In this tutorial I will show you how to create a parametric vertical tank family in Autodesk Revit. This video is intended for advanced users, so I won't explain every basic step in detail, but I will walk you through the important parts as we go. By the end of this tutorial we will create a vertical tank family with a shell and top head with two interchangeable types controlled by properties, Torispherical or conical, a bottom head with two interchangeable types controlled by properties, also Torispherical or conical, supports such as legs or lugs that can be switched through properties, and connectable nozzles. We will build the tank step by step using separate families for each main part and then load them into the whole family. This method is very useful because it makes the equipment easier to control, easier to edit and easier to reuse in future projects. As a host, we will use family created based on our equipment template that we recently published to our channel. Here, as you can see, we already predefined a lot of parameters with different values and under different sections. So as you can see here, we have some MTO related parameters, some wall thickness, some extra categories that I would like to introduce for easier data navigation in the model, then some basic dimension related parameters and also process related conditions. So this family we will use as our host family, or let's say sub-host, because for sure once we will finalize and bring all the geometry together, we need to once more load it to another container because it will make some of the operations easier. Here, as always, I'm going to create new family based on the metric generic model. Then I need to go to the front view, and on the front view I will create several reference planes. First, to indicate the top part, then the edge of the shell of the tank, then wall thickness, and also here I would like to introduce insulation thickness. For outside diameter, I will mirror it like that, just to have better control over the dimensions and to not overcomplicate it. This we will name as D for diameter. Here we're not going to use any kind of shared parameters just because we don't want to make it too complicated, at least at this stage. Then it will be wall thickness label, WT, then insulation thickness. I will also name it simply IT. Then we can create a geometry. It will be the shell part with axis of rotation right in the center of the family, and we'll create insulation. Also we'll use revolve tool, and as always we need to indicate axis of rotation. Then, as you noticed, one last left, and it should be height of the shell height. What I will do here extra, I will also redefine the material of the insulation, just to make sure it can be recognizable. To do that, I will just go here to material section, and instead of by category, I will change it. For example, I would like to have it according to glass. Yeah. So it will be healthy transparent, everybody will see that there is something inside, and then it will also should be clear that it's insulated equipment. Then I'm going to save it as shell, and that's it. Then I'm going to update here that I would like to have it work plane based. And then I'm going to load this family to our host family. Shell is ready. What I can do here already, I can map those parameters to the parameters we have defined here in our project. So D will be equal to the tank diameter. As you can see here, it was set to 0 because I haven't predefined any values related to dimensions. So let's do it right now. So let's have it 2 meters. Legs diameter, let's have it 150. Legs height 1.5. Legs width 100. Shell height 3 meters. Top cover height, let's make it 300. Insulation thickness of top cover, it should be just in a different category, so it's easier to distinguish. So I would like to have wall thickness equal to 20. Top cover wall thickness also let it be 20. Then here I have insulation thickness of the top cover. I would like to keep it, let's make it everywhere 70. So insulation of the tank also will be 70. This one I can also update to change it to see it in a different place, just to make it easier. And then it will be again 20 and again 70. Then let's see what do we have here. Bottom cover, let's make it 500. And the rest is just text, so it's not that important for now. And even though we're not going to fill it in this family, we're going to do it in the next one, in the host family. Okay, I think that's it. Then I can map also the shell height, then insulation thickness, and the thickness of the shell itself. Like that. Here in our semi-host family, we're going to define several extra reference planes. Why do we need it? Because, as you saw before, we made this family the work plane based. So that means this family is directly attached to the reference planes where it was placed. And technically, once I change the the reference plane, for example, I will call it here 111 just to make it simple, to make sure that they can see this reference plane as a reference in this menu. We need to ensure that the reference plane has some label. And to add label, you can easily find this field over here and type just something, like I did. And then, later on in this list, you can find it. And once I change the reference plane, you can see that the component was moved. And now, when I move the reference plane, the component moves alongside with that. And barely that was the whole thing. And now every component that we are going to place, depending on which kind of component is that, we are going to associate with proper reference plane. So for example, this reference plane I will call it 222, and this reference plane I will use to place top cover and all the nozzles that we have above this line. Then this plane will be used for bottom cover, both type of legs, and also for the shell. We are going to create missing parts. Then as a base for the top cover, as always, we are going to use metric generic model template. Here I'm going to start to draw it from the front view. What I will do, as always, I will define the diameter of the tank, wall thickness of the tank, and also insulation. To make it cleaner, I need to mirror it, because then it will be just a little bit easier to define all those dependencies, especially when you're dealing with various types of geometry. So this will be wall thickness, and this will be insulation thickness. Let's give it labels. Insulation thickness, wall thickness, and diameter. And of course we also need to predefine the height. As I mentioned in the beginning, we will create several types of heads. In this case it will be Torispheric head, and the next one will be conical head. Torispheric head we are going to create using also Revolve tool. In Revolve tool you need to find partial ellipse and just start to draw. Then we just need to shorten it to ensure the rotation will happen without any issues. Also will indicate the center line of the rotation. And the next one, with the next move, we are going to define the thickness, wall thickness of the element. And I will do it like that. So we're barely repeating the same action. We just need to go here and select it. What I will do over here, I will also define it as a wall thickness, just to ensure that it's always the same. And I'm going to enclose it from both sides. And now, when I will close it, and if I would like to adjust something, you will see that it adjusts accordingly. Wall thickness also reduces, which is correct behavior, because we do not change it. We do not change any other parameters. As you can see, everything is responsive. And in the same way, we are going to define the insulation of the top cover. I'm also going to do it with the same tools. So like that will be the first move and the second one. Second one will be matching to the first one that we made. And the first one, we just need to ensure that it's always will be equal to the insulation thickness. Like that. We're going also to close it and define the axis of rotation. As you can see, we accomplished it. So now I will also redefine the material of the insulation part. So as you can see, now we can see it clearly. Now, as I mentioned before, we will also enable work plane based. Here I need to go to the top view and I can just load it, but before let me save it. And now we can load it back to our semi-host family. As we did it with this part, we are going to do the same over here. you need to select the family, click on edit work plane, and select reference plane 2222. And as you can see, it moved accordingly. And if I would like to change this part, then it will follow up. We also will map parameters that we have over here. It will be diameter, then it will be height, top cover height, then insulation thickness of top cover, and the wall thickness, of course. What I will do right now, I will modify this family, but before I will resave it, and I will save it as conical. Why I did it like that? The reason is very simple. Later on, I would like to make sure that this family can be replaced with another one. To do that, the parameters that family has should be exactly the same. So the labels of the parameters should be exactly the same, and also quantity should be matching. Otherwise, it will lead to failure of the function and exchanging of the shapes. Later on, I will show you why it matters and how actually it works. So I'm going back to my shape that I have over here. I already deleted the geometry that I don't really want to keep in case of the conical shape. And now I'm going to define 2 extra reference planes. Why do I need it? Because I would like to indicate that I would like to have exit or entrance or vent on the top of the conical part. If you like, you can also just make it equal to 0, then it will be just conical shape enclosed without any kind of openings on the top. So this one I will call D1. What's important in this case, as I mentioned before, you need to ensure that families that you're going to exchange in place has same number and names of the parameters, with one addition. In Revit, there is a bug, so you cannot use lowercase and uppercase of the same character, because it will corrupt when you will try to change one family to another. So always ensure both of the families has similar characters, but with some extension. For example, this is why I used here D1 instead of simply D, because when I will try to swap components in place, it will swap also those parameters, or it will keep only one of them. So try to keep it always in your mind. And we're going to continue. We also will use Revolve tool. As you mentioned, it's my favorite tool in this case. I will do it the same as we did it before. Then, what I can do, I will also add one extra for the wall thickness. But it will be only these 2. Oh, pardon, 3. Then I will also enclose the geometry, otherwise we cannot create rotation. And it will be it. And now, when I start to move components, the geometry will adjust correspondingly. Yeah, as you can see, only one place is exception. And it sort of makes sense, because to ensure that it adjusts properly, we need to also make sure that this one always will be equal to the wall thickness. And now, when I start to move it, it still says, yeah, because it tries to adjust both of them. Yeah, as you can see now, it works fine. And with the next move, I will define the thickness of the insulation. I will also use revolve tool. Here I will do the same. With one exception, we need to add extra reference planes. I will do it over here. Yeah, from one side should be sufficient. And here I will do the same as we did it over there. It will be insulation thickness. And just to ensure that it will always locked in place, we define the extra reference plane, and we're going to bind it to that newly defined reference plane. Then we will just use reference planes defined here just to lock the geometry. And close it. Yeah, depending on the insulation you have, you can make it differently or of understanding how it's done. Depending on the shape and the type, it always will be different. So for me right now, it's not that important. The idea is just to show you how it can be done, and later on you can play with that. So now insulation thickness can be changed. Let me see, dependencies are not satisfied. So let me just try to adjust it to see if geometry will fail. Correct. No, geometry is not failing. So our last step, as always, will be to change the material. Glass. And basically that's it. Now we create a top cover with the conical shape. Here we have work plane based already enabled, so we can just load it to our semi-host family. Let's double check. Yeah, as you can see, that's what I mentioned before. We need to ensure that before the family placement, we have selected proper view. Otherwise, we saw what happened. And here I can adjust the reference plane. Not the reference plane, of course, but the base plane. And actually, what I currently did, you don't need to do. Yeah, it's very confusing, but I will show you why. The thing is, here inside Revit you have one special type of parameter. It's called family types. With this parameter you can dynamically swap in places instances that you have currently. Here I will call it top cover shape. It always should be parameter of instance, just to make your life easier. And this one I can easily delete. And what I'm going to do next, here when you go to parameters, under other you will find parameter we just defined. And here we have available the list. Well, what I can do now, just to display it to you, I can just change. Oh, let me make it a little bit bigger. I can change Toro conical, and I don't need to map all the parameters from the imported family because they've been already mapped from the previously defined family, so from the Torispheric part. Yeah, and also as you can see, actually we made a mistake from point of the defining the insulation, because insulation thickness in case of the conical part should not be defined in such a way. As you can see, the value is totally different when you try to measure it in that way. So what we need to do, we don't need those reference planes that's over here. We will just use the original reference plane as a base. Then with this dimension, they always will be parallel. And now when I will define it this value, and if we will try to change this one, as you can see, the angle is changing dynamically also. And actually this will be the correct way how to define the insulation in this case. And once I overwrite it, you can see that it's a little bit different. And actually this will be the correct way how to display it. Only thing, how to be handled in this place. But I leave it up to you. Of course, we can also make it a little bit different over here, but I will not do it right now. And anyway, here, if you will change the height, for example, to 600, then it also will be a little bit different. Here you can define some additional elements or subtractions to make it usable for in your case. Well, that's how we created the top cover of the tank, and also we made it dynamic so we can easily swap it in places. Now I'm going to show you one thing that I mentioned before, why you need to ensure that you always have maximum number of parameters. So if you would like to ensure that the families are exchanged or swapped in places in a proper way, and you don't need to always modify anything, you need to ensure first that every family that you're going to exchange in places has same number of parameters. In this case, as you can see, I have one extra, and if I will try to bind it to, for example, I will name it vent diameter, and if right now I will try to replace it with different family was replaced, and technically nothing went wrong, but now when I move it back, this parameter will be not assigned anymore. So even if in your case this parameter will be always equal to 0, you still need to mention it, and you need to bind it to the desired parameter. And this is what I'm going to do now. I will click on edit over here, and I will just define d1. That will be equal 0. Yes, close it. Done. And now when I will change it, here as you can see it was assigned. Nothing happens with the geometry because there is nothing connected to geometry, only parameter is available over there. And when I move it back, it's still binded. You don't have to always to rebind it. And now we will repeat the same exercise for the bottom cover. Now this one I can close. We don't need it anymore. So I will just do the same. I will open family that I created before. I will simply save it with different name. Bottom cover. And I will just mirror the geometry. And that's it. Yeah, of course, I also need to adjust some reference planes and ensure that geometry is properly redefined. To do that, I need to do some extra operations just to ensure that it's properly connected to the reference planes, and we will not have any surprises later. Ensure you did the same. Otherwise, later on, you might have some issues. Wall thickness. Now we can close it. And that's it. Same I will do for our insulation. Then I will also close it. And that's it. Now let's check how it works. Yeah, this part is working. This one refuses because there is no equation. So just to give it a check, I will change wall thickness to 20, insulation thickness to 100 for example, height I will change to 500, D let's say 300, and diameter let it be 2000s. Yeah, as you can see, it's working, so there shouldn't be any issues. Yeah, this one we can remove quite easily without any problems. And now we can load it to our family. Here as you can see, we already have work plane based option selected. And now I need to go to the top view and I can place it over here. And I can select connected reference plane, so it moves. Then I will also remap it. Simple as this. Then, with my next move, I will repeat this exercise for the Torispherical cover. Let me just rename it, because I made it typo. And now I can edit this one, this family. I will also just rename it. Bottom cover, Toro. And we will do the same, just mirror copy. This part can be deleted. This one we will just move it to the bottom. Yeah, here I would advise you to redraw it completely. Still, because of, yeah, time to time this shape works unexpectedly, so it's better to spend a little bit more time than changing everything later. I will do the same over here, because it should be equal to wall thickness. I'm also going to close it. Then I'm going to add axis of rotation. Same exercise I will repeat for our insulation. Yes. It also will be stopped here. I can also draw piece of rotation, add a few dimensions, insulation thickness, obviously, and we're going to close it. Material was already applied, so from this point of view it should not be changed. Work plane base also selected option. Now the only thing we need to do, I need to load it back to our family. It was already renamed. So here I'm also going to define similar kind of parameter. Bottom cover shape. Also parameter of instance. And as in first case, it can be easily swapped in places. This is one of the ways how you can have it done. Now I will do a few other steps that so far we skipped. So we haven't defined labels for the height of the legs and the height of the shell. Yes, here how we defined our main shape of the tank. Now we're going to model legs. With legs it will be a little bit tricky because you need to understand how it will work later. In this case, in case of the legs and lugs, lugs we will have on that side, so above the reference plane, and legs will be below the reference plane. Now we will create leg family using metric generic model template. Later on, this family we will load into another family where we will use it to create an array, just to have cleaner family. And I'm going to start from a few very simple reference planes. So it will be plate of the leg. I'm going to equalize it. I will give it very simple label without overcomplicating it. It will be simply W. You can just select it. Then with extrusion, let's lock it. Then I will add one more reference plane on the front here. I will call it PT, plate thickness. And then I will create the extrusion for the leg. This will be leg diameter. And actually here, as you can see, I did it as I shouldn't do. Why? Because this is the reference plane and this will be used as a base of placement of the component. So what I need to do, I need to create reference plane lower than this level. Then I will move components that I created. Let me just delete it. Okay, I need to do it component by component. Now I can move it. And reference plane also can be moved here. Now, this can be used as the top of the geometry. And this will be our leg height. Yes. Here I will repeat it. It will be plate thickness. Yeah, to make it cleaner, of course, you can also do it like that. This will be our first leg. Then, what I'm going to do, I will create separate family. And I will load single leg to this newly created family. First, I will map all the parameters from this family to our host family. And why I did it like that? Because I would like to create an array. And based on my personal practice, if you would like to create some of the components out of using arrays, or if you would like to create some of the families using arrays, you need to create separate family that you're going to use inside of this array to not overcomplicate your family, because then later you need to deal with all the reference planes, lines, etc. That's what I don't like. So I would prefer to have nested families involved. And now I just need to select radial array, then second or last. In my case I selected last option, and I'm going to do it like that. Then as you can see it was only 180, and I'm going to move it to 360. Here I'm going to define extra parameter. It will be called number of legs. So via this parameter we can define how many legs we would like to have. And one extra parameter will be how those legs should be placed. So I will call this parameter d1, and here I'm going to define separate parameter d that will be equal to the diameter of the tank. What here I would like to achieve, I would like to ensure the geometry of the legs that I'm going to create will not go beyond the shape of the tank we are going to model. And to do that, I can simply achieve it with one expression. So what I would like to have, I would like to ensure that my legs, they are always, first of all, by default, the leg center always will be at the edge of the tank, but I don't want it. So that's why I'm going to do it like that. D minus D minus ID divided by 2, and for example minus 50. I would like to have extra 50 millimeters gap, or 25 millimeters in this case. Yeah, let's make it 100, so then it's visible. Then I will call it Lugs. Here now we can also enable option work plane based, and then we can load it to our semi-host family. The only thing we need to do, of course, here in this case, we need to go to the reference plane and then place our leg set. Then we can select proper base plane that you would like to use over here. And then here I will map all the parameters. Will be diameter, leg width, then leg diameter, and then leg height, and plate height. Let it be equal to the wall thickness of the tank. As you can see, something went wrong somewhere, so let's give it a check to our families. Yes, this should be correct. Okay, yeah, I think I found it. The geometry hasn't been binded to the reference plane. Now I think it should be working. Let's give it a try. Yes, now it works. And to make it correct, I'm going to adjust those dimensions, and as you can see here how it goes. Now we're going to add value to our legs number parameter. It will be 4 in this case, and here I'm going to bind this parameter also. So now we will have 4 legs. And if we would like to change the height of the thing, or if we would like to change the height of the legs, do it like that, and as you can see, it followed up. That's it. Now I will use main family as a base to create our lug family. And of course, this one we will redefine completely. What I will do here, yeah, probably the previous one I could keep, but doesn't matter for now. So, how I'm going to create lugs? I will use same W parameter, and then I'm going to define a few extra parameters. case of Lugs, of course, I need parameter of length. Parameter of the plate thickness, and a few extra reference planes. Yeah, let's make it a little bit bigger. Again, it depends on how you would like to create your lugs. In my case, I will use shape that I'm about to draw. It will be extrusion. Then with this extrusion, I'm going to define my lug shape. Like that. This part I'm going to rebind just to ensure it's properly connected. I do the same with the shape that I just created. As you can see, those are already properly connected, so let's not waste time on it. In this case it worked fine. Then I'm going to add one extra label. I will call it L1. And here I will define it in a very simple way. If you like to make it differently, it's up to you. I will just ensure that plates will be positioned equally, and the thickness of those plates will be equal to the plate thickness. If you would like to, you can add more references or dependencies. In my case, or at least for me right now, it's not necessary. You can do and add as much details as you want. Here, let me see. It should be equal to L, and we're going to define it with L. Correct? Let me double check it. Yeah. And now it looks like lag. Now we can load it to our lug set. As you can see, when I just override it, it immediately stands in place. Now we need to define a few extra parameters. In this case, it will be L and L1. And here, as you can see, expression we defined before, actually we don't need it. And I would make something a little bit different. Or it really depends on what you would like to have. But in my case, I would like to slightly move it inwards, the tank geometries. So then it looks like it's within the body of the tank. So it will be D minus L1 divided by 2. And I think it should be sort of okay. Let's load it to our semi-host family. Now I can create another type parameter. I will call it leg. And here, as you can see, I can change them as we did before. But to me, still something looks quite suspicious, yeah? Because we're changing the configuration of the legs. But if we will do it within the same model, within the same family, then this family will be just flying in the air. And that's what I don't really like to see. And additionally, of course, we should be able to define the position of the lugs, because for sure lugs can be placed on different elevations, but at the same time legs always should remain at the same place. So how can we do that? To do that, we're going to define a few reference planes. And we're going to delete also a few reference planes. Here I'm going to add one parameter. The total height of the tank. Let me see if I have it somewhere. Not really. Okay, then let me just use generic one. So it will be height of the tank. This will be equal to the height of the top cover. And our lug, I'm going to redefine it to the new reference plane that I just defined. So it will be called leg lug. What I will do next, I'm going to select all the reference planes and I will make them not a reference. So when we load this family into another family, we cannot interact with those reference planes. In case of this family, I will modify its reference only for this one, for this reference plane, that we will use as a base for legs or lugs placement. And this one I will convert to strong reference. So now I'm going to define a few extra parameters. This one I will call lug level. And as I mentioned here, I'm going to edit work plane to leg lug. And now, as you can see, the level where lugs are placed can be changed. And yeah, I noticed one thing. It seems like we forgot to do that. Correct. We haven't defined the height. So I'm going to fix it quickly. Load it to our Lugs set. Bind it to parameter height. And here I also need to bind it to parameter leg height. And as you can see, what just happened. But we will go into solve it a little bit later. Here I'm going to define those parameters. In your case, you can make them more explicit, so you can always modify them. And as we just noticed, our Lugs family are missing those parameters, L1 and L, so we need to add it, otherwise we cannot replace them. As in case of the Torispherical head, I just need to have them. It's not mandatory to do something with them. They just should exist. And now, when I will change it in place, as you can see, here everything was kept. And once I swap it back, again, everything was kept, except the height. Wait. Let me check something. Probably here we also forgot it. No, we haven't forgot it, but it was called different. And of course we already had it here. So only thing I need to do, I need to rebind it to LH. And this parameter I added can be removed. Yes, that was one mistake. Yeah, for now let's keep it as it is. It's not that important. At least for now. We're going to fix it right away. But still. And what are we going to do with this mess? With this disaster? We are going to fix it by adding a few extra parameters. First of all, we are going to define a few extra parameters. First parameter, I will call it L1. This parameter will be calculated based on the expression that I'm going to define right now. It will be overall height minus the top cover height and minus the shell height. And as you can see, with this expression we gain the leg height. And that's what I'm going to do right now. This will be the height of the legs that we would like to have. And now I'm going to define one extra parameter. Yeah, let's call it LH1. And what this parameter will do? This parameter going to help us to define the height of the legs. And how actually are we going to do that? To do that, we're going to add one yes/no parameter. Yes/no. I will call it also leg lug. From one point of view, it will make it simpler for us to switch between two different configurations, and from different one, it will also give us some options to select from. How to ensure that it's working in the correct way? To ensure it, we need to create two extra type parameters. I will just keep it generic. I will call it lug. And another one, I will call it leg. So this one I will redefine to lug. Oh, no, wrong one. Here I need to move it, shift it back to leg lug. Then here I need to swap it back, leg lug, and then I'm going to define one expression. What I would like to have. We can define it with expression. It will be if leg lug section is true, so the checkbox is enabled, then I would like to see leg. I would like to see leg, otherwise I want to see leg. So as you can see here in this formula, I just used the values of those parameters. And behind of each parameter, I have a certain type selected. So technically, if you would like to, you can also do the same for the top cover shape and bottom cover shape. For now, I will not do that. If you'd like to, you can do that following same steps. Now we have a little bit of a puzzle. So from one point of view, we have this option enabled, but we also need to somehow to convert it to dimensions. And we're going to do it quite easily. So we have parameter name, leg lug section, and we know that it is true or false. If it's true, that means select it is enabled, and if it's false, that means it's not enabled. And I'm going to define this parameter with equation. If leg lug section is true, so we would like to see legs, we're going to use LL1, and if not, I'm just lazy in that sense to type all of that. We're going to use leg height. And now, for example, by default, we can make sure that our leg height, we can even, for example, if you would like to, in case of family like that, you can even rename it just to keep it as leg height. Or yeah, actually it's up to you how you would like to handle it. I just did it right like that in that sense. I can make it equal to 500. And what I have now, when I will turn it on, legs. Yes, correct. Because here we haven't reassigned it to the property that we currently are using to define the leg height, and it's LH1. And as you can see here, still something feels off, because we still have this parameter available. And actually this is one of the things that I would like to change. Here, this value also will be defined via the expression. I will call it HH1. And here will be almost the same expression. It will be leg lock section. Then if leg lock section is true, then I would like to have this value equal to 0. And if leg lock section is false, so I would like to have lux, then it will be equal to lock level. Simple like that. Now I just need to change it to LH1. Oh, pardon. For sure, not LH1, HH1. Yeah, now it's working correctly. So now, when I would like to have lugs, I can have lugs, and I can add offset for the level of the lugs placement. But once I change my mind and I would like to have legs again, it will go back. And that's how you can control it. The only thing that's currently still missing is how can we properly define the baseline of the family. So how we can ensure it will have consistent placement across several configurations. Because probably, as you know, this location should be the center of placement. So every time when you position it somewhere within the building or on several levels, the base of the family always should be equal to this spot. So reference level always should be equal to the level of placement of the equipment. Then you can have full control over your model. Otherwise it will be chaotic. And how can we do that? This can be achieved quite easily, but to do that we need to create additional host family, and actually it will be like a master host. We'll have only one dimension and the rest of the dimensions will be coming from this general family. Here, as you can see, we already added quite a few parameters, so I will just skip it. Yes. And what I will do, I will resave this family as you can see, I worked directly in the template. Shouldn't do that, but okay. I will call it semi-host. Equipment, and the next one I will call equipment host family. And inside of the equipment host family, I'm going to delete all the loaded families. And what I will do, I will open semi-host. I will ensure that it's also work plane based. Those families I can close. Here I can navigate to the top view, and I'm going to place this family. Here it is. Now we are going to create one extra reference plane, and we are going to create additional parameter that will help us to position the equipment. And here I'm going to define extra parameter. Let me call it just ZZ. And here, what it will be, if leg lock section is true, then it will be LL1, otherwise it will be 0. Now I just need to bind parameters that I can. As you can see, some of them I cannot bind. Yeah, so this family can be used as a template, but it cannot be modified out of the project. That's, yeah, one of the disadvantages, at least in this configuration, yeah. How you can make it sure that you can also change it, you can add one yes/no parameter, and then it will be not an issue. I'm going to bind all of them. Now, when we binded all of them, we can give it a check. Yeah, as you can see, in this configuration, our center point always will be at the reference level. Just to give it another check, I will change the diameter of the tank. Yes, it worked fine. Top cover height. Overall height. Bottom cover height. And for example, I would like to change the lug level. And as you can see right now, we have a responsive family. And our final step will be to add nozzles to that family. And now we need to add one more reference plane and ensure that all the nozzles are connected to this reference plane, so then we can freely play with other parameters of the model. Now, when you would like to bind two reference planes, ensure that you selected reference plane with tab, but not something different. Then let's define additional parameter. I will call it ZS, and ZS itself, I will define it with shell height minus HH1. And now, when we change configuration to Lugs, this reference plane always will be in place. And now we can start adding our nozzles. You can download this family from our website. Over here. You can also find it like that. Just type and search nozzle, and then you can find this family. And I can download it. Yes, and I'm going to use it straight away. Now I can load it to my equipment host family. And I'm going to place it somewhere over here, for example. What I will do here, additionally, I'm going to change it also to be work plane based. Then, for certain, it will always be connected to one of the reference planes. And in my case, I need to ensure that it will be connected to nozzles placement reference plane. And as always, I can do it like that. Here, just to make it more realistic, what I will do, I will change the angle everywhere to 0 degrees. And I will try to position it in the location where I would like to have them. For example, let's have it on -500. The other one, let it be somewhere lower. When you copy them, ensure that they remain associated with the correct reference plane. As you can see, when you try to copy them, the connection disappears. So probably what will be the best, if you can just copy several instances, because you can assign all of them at once to the same reference plane, and then you can start to move them. Yeah, let me do it a little bit differently. First, I will mirror copy them, and then I will create several instances. Just because I would like to have a lot of nozzles in the model. All of them went down, and now we can start distribute them. This way, a little bit time consuming, but it has some advantages. One of them, you can have full control over your nozzles. And even when you change the geometry of the equipment, nozzles will remain in the same place. As you can see here, yeah, they are not hanging in the air because they are connected to this reference plane. You can position nozzles wherever you want. For now, we will not take care of it. It was just a sample to show you how it can be working. And as always, thank you for watching, and see you in the next video.